So hello, myself Govind Singh, and today we'll be solving the problem B of Codeforces round Goodbye 2022. So it is the last round of this year, and let's see what was the problem statement. And we are given two integers n and k, and we have to construct a permutation of size n. Okay, so I hope you will be knowing what is a permutation. It contains all the elements from 1 to n exactly once in any order. Okay, so if I have to construct a permutation of size 5, and let's take any permutation, like it could be 3, 4, 1, 2, 5. So it might be one permutation. So what is given next? Like we have to make a array C, which is of length n minus k plus 1, and its length will be like, if suppose k is 3, then the length of the array C would be 5 minus 3 plus 1, which is 3. Okay, so we have to construct a array of size 3. Okay, and now what is given, the ith element would be like the maximum of pi to pi plus k minus 1 of this. Okay, if k is 3, then this box will contain the elements from pi to pi plus k minus 1. Okay, so we have to take maximum value among these, and we have to take minimum of value among these and add them both and put it in here. So here the maximum value would be 4 and the minimum value will be 1. Now sum would be 5. Now if we take the next box now for the I equal to 2, then this will be our box, and their maximum is again 4 and minimum is again 1, then it would be 5 again. And if we take this box, then the maximum is 5, minimum is 1, then it would be 6. Okay, so what is asked, like okay, so the cost of permutation will be the maximum element of C. Now this is the array C, and the cost will be the maximum value among these, and we are told to minimize this cost. Okay, we have to construct, this is a permutation, right? So we need to construct such a permutation which is having the minimum possible cost. That means the maximum value of this of this array C, it should be as minimum as possible. So let's see how can we make this permutation P. So we can see here, like we are only asked the for a box, we just need its maximum and minimum value, right? So let's try to make a let's take the same example, n equal to 5 and k equal to 3, and we want to make a smaller array. So there could be multiple approaches or ways to make permutations. Also, even you can see, like if you only make this 6 1 5 2, like if it is an array of size 5, then you can make 5 1 4 2 3. Now this would be working. First you put a maximum greater element. Now how would you made it? We have 5 numbers available. We have to use all 5 of them. 3 4 5. First we take the larger number, then a smaller, then a larger. Like first we take 5, then 1, then 4, then 2, then 3. Now this could be one of the solution. Okay, without the value, without concerning the value of k, if we print this, then this would be one of our solution. So there could be multiple approaches, but let's see some other approach, like how else could we do it, and which could be more reasonable for putting this value of k. So if kn is 5 and we need to make a permutation of size 5, like 1 2 3 4 5, and we have 5 numbers available, 1 2 3 4 5, we need to make use of them. So what we know at a time, we if we take any box like which is of size k, we know that we have to construct a array C, which would be having the elements from the maximum among these and the minimum among these. So we know that if we take the maximum, if we put the maximum element in the front, and the if we take the maximum and the minimum element in this box, then it would be better, right? Because if we take the maximum and the the next maximum, like if we take 5 4 3, then the maximum would be 5, the minimum would be 3, then they would give me a sum much larger. So I don't want that. I want, it should be as minimum as possible. So for that I can take the maximum, and along with that I can take the minimum. So I can take the maximum, I can take the minimum. Okay. So but I know that I am also only concerning about this maximum and minimum, right? If in this box I want one minimum, and I want this, for the whole array, the cost should be as minimum as possible, and so I would be requiring more smaller elements. Okay. Okay, if I am putting a 1 here, okay, so whatever number I put here, the value will remain unchanged, right? Whatever number I put, the maximum will be this only, the minimum will be this only. So what could I do? What better I could do here is, like, I should put a bigger number here. If I put a bigger number here, then there will be lesser, smaller numbers left behind, so that we can make use of that, which will give us a more smaller, the more smaller cost, or the minimum lesser cost. So we know that in a box, if we are putting a bigger maximum element and taking the minimum element, and then take then we can take the next bigger element. Like if we taken 5, we taken 5 1. Now next we can take the next bigger element. If we put 4 here, then it would be, it won't be concerning, it won't be contributing to the value of CI. But we just we lost our, we removed our, the bigger value, which will make hurdles in making the permutation. So we just removed this 4. uh, so next what we can do, like, for this 4, now the next values that will be remaining would be 3 and 2. Now I can take the maximum value, then the minimum value, right? Now taking any other values, like, why I have put 1 here only? If this is one box, if this was one box, I could have put 1 here also. But if I put 1 here, then I would have to put 4 here, and then this array would be having the minimum value as 2, but I want it should be 1. So I should be, putting these minimum values in the middles, in the in a in a possible way, such that whatever sub array I create, whatever box I create, like I put ones in such a place, like whatever box I create, if I take this box, then there would be a 1. If I create this box, then there would be a minimum value. Like if there are more elements, then I this is the minimum value for that, right? So if we take that box, then this would be the minimum value. If we take this box, like 2 is not there, then here are 3 values, and among which we are putting one smaller, one small value, one big value, and one next bigger value than this. Okay. So this is how we will be doing, and now let's see how can we implement it. It is a very easy way of implementing. So what we will do, first we have 5 elements, like 1 2 3 4 5. Now we can take the first one. These are these indexes, and first we will take the bigger value, and what we will do, we will put all the maximum values. Like this is a 1, I will put, like, consider a string of this permutation of size 6, then I guess it would be much clear. And I have to create 6. Now what I will do, I will put this minimum value here, and this minimum value here at the integral multiples of k. On the multiples of k, I will put this 1 and 2. Now if I put the any values here, now if I put the maximum value here, this the bigger value here, and then I will put the next bigger value here. then 4 here, then 3 here. Now this would be giving our say correct result. You know, whichever array I take, like if I take this segment of size 3 for the which is which we need for this CI, the array. Okay, so it would be having a minimum value. Yeah, if we take this, now this is also having a minimum value. Yes, now this is also having a minimum value. So whichever box or subarray we take of size k, it would be having a smaller value. Okay, so this would be giving us our correct result. So I hope it is well enough clear to you. Now then also you have any doubt, you can put that in comment section. And that's all. Thank you.